Right, section 3.4 is hopefully a topic you're familiar with. It's going to be applications of lines, of linear equations. Right, and then we'll get into other types of applications later on in the chapter. Right, so the first part, I kind of broke this into part one. If you need a quick review of lines, again, this should be stuff you're very familiar with. All right, so an equation of a line, there's two forms that usually you see in an algebra class. There's the y equals mx plus b, which is, again, the form we will be using the most, where the equation is set equal to y. We have a number times x plus a number. This is called the slope-intercept form of line, where it's the slope-intercept because that's what's given to me. The m part of this equation, that number in front of the x, is the slope. The b part, the number added at the end, is the y-intercept of the function. It's the point. Usually it's considered the starting point. At time 0, at amount 0, b is my starting point. Right, the other form is the standard form, which again we won't be using as much, but it is a form that you should be familiar with. The standard form is when I have a number times x plus a number times y set equal to a constant. And again, a, b, and c are just real numbers, and that's a linear equation in sort of standard form. But like I said, we will be utilizing the slope-intercept form because most of our applications, either we will be finding slope or given slope. Slope is very important piece of a linear function. It's constant or fixed for the entire function. It's important because it tells us how fast, if it's a big number, or how slow, if it's a small number, my function's increasing, moving up, or decreasing, moving down. I mean, it's constant because no matter where you are, so suppose that my linear function represents cost. My cost would be, if it's a positive number, again, it should be a positive number for cost, cost should be increasing at the same rate no matter what time period I am. If I'm in the first week, first day, first month, whatever, it's increasing at the same speed no matter what time on my line I am. Or if it's a decreasing function, again, same idea. Suppose the population is decreasing linearly, meaning I'm decreasing at the same speed no matter where I'm at in my line. Alright, so again, that's a constant rate of decrease. My function's changing by this speed no matter where I'm at on my line. Alright, it's usually called the steepness of a line, how fast it's moving up, how fast it's moving down, or how slow if it's a small value. You will need to understand and be able to find slope, the rate of change of a linear function. Alright, so that's the m part in the y equals mx plus b. Alright, so if you're given, either you'll be given it or you'll have to find it. If you have to find it, oftentimes you'll have to have 2 points, or a graph and be able to locate 2 points. So if we're given 2 points, so first in words, what it is, the slope is the change in y, the change in the function values, over the change in x, the input values. Sometimes, again, delta y over delta x. Delta is a mathematical term for change. In simple terms, you usually first learn it as rise over run. Rise meaning how much my function's moving up as x values change. The run would be the x values as x values increase. Or if it's negative, it's moving down. The equation is what's the change in y. So you take your y values and subtraction. Usually we take y2 minus y1 because y2 is usually bigger, but doesn't have to be. And then divide that by the change in x, which would be the difference in x. So again, the biggest thing with you can actually subtract it the other way. The biggest thing is make sure you're consistent. The first 2 values of your subtraction should come from the first point or the second point. And then what you subtract y, they should come from the same point. Again, what it finds speed. It finds how fast, if it's a big number, or slow, the line, the function, is increasing if it's moving up, positive, or decreasing if it's negative, per change in x, whatever that x value unit is. So if x is time, it'd be the how fast it's moving up or down per change in time. If the x value is items, it's how fast it's moving up or down per change in items. Alright, so again, it's the increase of my function or the decrease of my function, and because it's linear, it's moving at the same speed as I go up and the same speed as I go down. Alright, so the first example is a simple example. Find the linear equation, or the equation of a line, where I have a slope of 7 and a y-intercept of 2. So in this case, they gave us the slope was 7. They gave us the y-intercept was negative 2. And so when we fill out the y equals mx plus b, m is 7 times x. And then plus a negative 2. We typically write that as subtraction, so you would really find it 7x minus 2 would be the linear form that we'd want. Again, the negative 2 would be, this has a point at 0x, negative 2y. The slope 7 means, well, this line should be increasing at that rate. So that means it's increasing at a rate, a speed of 7 units of y, whatever y is, per change in the x units, whatever x is. So it's moving up, y goes up by 7 units when x goes over by 1. That's what that means. So if it's a cost, its cost is going up by $7 per change in my value x, whatever x would represent. Find the equation of a line given the graph below. So if we're given a graph, we should be able to find the equation of a line. All right, so it means I need to locate a couple points, right, in order to find my y equals mx plus b. I need to find my b first, which remember, b is the point 0b. When x is 0, what is my y value? Well, x is 0 is here. I go up and hit my curve. Well, that's the point 0, 1, right? So my y-intercept is 0, 1. All right, so b is 1. Now slope. Slope, I need a change in y over a change in x. There's a couple ways you can do this. You can do the formula, and I'm going to walk through both methods. All right, so the first thing I'm going to do is I'm going to pull off 2 points. So I already have the point 0, 1. That's always a good one to have. And then a second point, I'll pick this as my second point. So 1, 4. When x is 1, y is 4. And so if I use my formula, which again you can always use, it's the change in y. Well, the y value, y2 would be 4. y1 would be 1, so 4 minus 1 would be my change in y. And then my change in x would be 1 minus 0, so I get 3 over 1, so my slope is 3. You can also use the graph. If you use the graph, we'll use the run and the rise, so that would be the part that we use. And so the run would be when the change in x is 1. The rise would be, well, how does my function change? Well, my y values go from 1 to 4, right? So that change would be 3, right? I run by 1, I rise by 3. And so we could get it the same way. When it's rise over run, the rise is 3 when we run by 1. So you could use that as well. And then again, I still haven't given my answer. I need the equation. I haven't written out the equation yet. The equation is y equals slope, 3 times x, plus my y-intercept of 1. So the equation of this line, if I were to graph it again, would be 3x plus 1. Next example, find the equation of a line that passes through the point -1, -1 with a slope of 3. So again, if I want my y equals mx plus b, I was given my slope, right? I know m. What I don't know is my y-intercept. But they told me a point, right? They gave me the point -1, -1, which means when x is 1, then when x is -1, then y is also -1. And so I'm going to use that. I'm going to plug all of my given information in. So I'm going to take my y equals mx plus b, plug in my m, plug in my y, and plug in my x. And then solve for my missing piece. Solve for b. Alright, so y is -1, slope is 3, x is -1, so I get -1 equals -3, right? 3 times -1 is -3. But then I have to solve for b, so it means I need to add 3 and move it to the other side. And so I get a 2 equals b. So my y-intercept is 2. So again, my final answer is the line is y equals negative 3 times x plus 2, right? My slope is negative 3, and I just found my y-intercept, which was a positive 2. And you can check your answer. Make sure when you plug in negative 1, you get negative 1 out. When I plug negative 1 in, oops, I put negative 3, and it should have been a positive 3. Okay, was it? Good thing I was going to go check. This is a good example of check your answers, right? I noticed that when I went to go plug my negative 1 in, I was going to get negative 5 instead of negative 1. And again, the reason why is because up here, I accidentally marked a negative 3, even though over here I wrote it down right. So B is 2, that's correct. And so in my final answer, though, it should have been a positive 3x plus 2. Positive 3 was my slope, right? That was the slope that was given to me, a positive 3. And so then now I check my answer and make sure it works again. So this is why it's always a good idea to check your answer. When I plug negative 1 in, now I'm going to get negative 3 plus 2. That'll give me out negative 1, and so my answer checked. So again, the answer for this should have been positive 3 plus 2. Alright, this one. Find the equation of a line passing through the point. So we're given 2 points in this case. So again, y equals mx plus b. So we'll find m for, we don't know either, right? Don't know m or b. And so we'll always find slope first in this case. So find your change in y over your change in x. So change in y would be y2 minus y1 over x2 minus x1. So we'll take the 9 minus the negative, and make sure you're careful. Or sorry, negative 3. Y minus the negative 3. Make sure you're careful with the negatives there. It's minus a minus, and it's going to be that way both the top and the bottom. So my x value is 4 minus a negative 8. And so remember, when you subtract the negative, you're really adding. So when I'm going to write that down here, it's really 9 plus 3 divided by 4 plus 8. And so then it becomes 12 over 12. 9 plus 3 is 12. 4 plus 8 is also 12. And so that simplifies to the nice number 1. Alright, so I know my slope is 1. Now for B, there's different ways you can do it. And if you know the point slope equation, you can use that. I'm going to use the same method I did in the last example. I know my slope is 1, and I'm going to use one of my points. So I'm going to use the 4, 9. So if I know x is 4, y equals 9, I'm going to take those values and plug them into the y equals mx plus b and solve for my b. All right, now I've got to be careful here. Make sure I plug in the y in the y spot, the x in the x spot, and the slope in the slope spot. All right, so y is 9. Slope was 1. X was 4, and b is what I'm solving for. And so I get 9 equals 4 plus b, and for some reason my pen stopped working. And so you'll get the answer is 5. Come on, pen, why did you stop working? Alright, I'll pick this up in the next video, so I'll start here and do the last example in the next video since for some reason my pen must have stopped working.